Yes, starting. Okay, so first of all, charge, valency. We have to learn all the valencies today. And then oxidation state. Oxidation state is something which is tricky. Now, you cannot learn oxidation states. That will be different all the time. Okay, so what is charge? Charge Charge is something which is due to transfer of electron, due to loss or gain of electron. For example, I have a sodium, for example. And if I say this sodium is the neutral sodium without any charge, this is the neutral sodium without any charge. Okay. So if I ask you that how sodium would react, so you will tell me, Miss, when sodium would react, it will. I mean, sodium belongs to group one now, and it has one valence electron. So whenever sodium would react, it will donate its one electron to to anything, जो भी इसके साथ non-metal होगा. So how sodium would react? It will donate its electron. It will donate its one electron. एक ही होता है, it belongs to group one. So it will donate its one electron. And when it is donating its one electron, means it is donating its negative charge, so it will become positive sodium. Okay. So this positive one, this plus one, is something which is the future of the sodium. Means now I have a pure sodium, a neutral sodium, जिसने कोई electron loss या gain नहीं किया है. So if I'm saying that sodium during reaction, it will donate its one electron. It will transfer its one valence electron. So it means its valency is +1. So what is the valency? The future of the element. That's what I'm telling, the future of the element. Okay. In future, when sodium will react, it will become +1 ion, or it will get +1 charge. It will donate one electron. This is the valency. Valency is the future of the element. Charge, I mean, valency is something which is fixed, but again, there are some elements जिनकी valency fixed नहीं रहती. During the reaction, वो बदल जाते हैं, वो change हो जाते हैं. So valency is something which is fixed. That whenever sodium will react, it will donate one electron. So ये सोडियम का जो फ्यूचर है ये फिक्स ही रहेगा ना. मतलब हमने सोडियम का जो फ्यूचर है वो ठीक प्रेडिक्ट किया है कि whenever sodium would react, it will become +1 ion. कभी भी ऐसा नहीं होगा कि सोडियम जो है वो +2 आयन बन जाए. It will never happen. Sodium has only one valence electron. It cannot remove its inner electron. So see, valency is something like a future prediction. Easiest word में बता रही हूँ so that you could remember. Then what is a charge? Past. Valency is future. The charge is the past. For example, if I say I have a sodium and that has +1 charge on it. Now this +1 is not telling the future of the sodium that it will donate its one electron. No, it is the charge of the sodium. So it is telling about the past of the sodium. Means sodium has donated its electron few minutes before. So this is the past. चार्ज होता है कि सोडियम ने मतलब एलिमेंट ने थोड़ी देर पहले अपने पास में कुछ किया. Either it has gained electron or it has lost electron. Charge is the past. Valency future. So ये तो बड़ा आसान सा हो गया कि जो वैलेंसी होगी वो चार्ज होगा. Okay. What is the oxidation state? The current state. What sodium is doing right now? How many electrons are sodium donating right now? How many electrons is sodium accepting right now? That is the oxidation state. Oxidation state, for example, I have sodium chloride. So everyone knows that whenever we make sodium chloride, this is an ionic bond. So sodium has donated one electron to the chlorine, or chlorine has gained one electron from the sodium. So sodium is +1. So this +1 is now oxidation state. So इसका मतलब है ये तो बड़ा आसान सा concept है. Means the valency, the charge, and the oxidation state, that will be remain same all the time. No. Let me give you an example. That is sulfur. Sulfur, oh, let's start from the valency for the future. Sulfur has -2 valency. I'll let you know about the valency, that किस group की क्या valency होती. For example, sulfur has -2 valency according to the periodic table, and this is fixed. What does it mean? It means when sulfur react, it will gain 2 electron and it will make sulfur -2 ion. This is the valency. This is the future prediction. Okay. अब सल्फर ने कोई रिएक्ट किया, आपको -2 चार्ज नजर आ गया, आप कहेंगे ओके sulfur has gained 2 electrons few minutes before that, so it has -2 charge right now. All right. After some time you got some more compounds of the sulfur. उसमें आपको पता चला सल्फर तो +2 भी नजर आ रहा है कहीं, सल्फर +4 भी नजर आ रहा है कहीं. What does it mean? Different charges. यहाँ तो अलग अलग इलेक्ट्रॉन्स हो रहे हैं. अच्छा, forget about the charges. चार्ज तो बहुत आसान है ना, कितने इलेक्ट्रॉन गेन हो रहे हैं, कितने लॉस हो रहे हैं. Let's move on oxidation state. For example, sulfur is making bond with the sulfur dioxide. Oh, sorry, sulfur is making bond with the oxygen and it's giving you sulfur dioxide. So what is the oxidation state of sulfur? So everyone knows about the valency of sulfur, that whenever sulfur would react, it will make -2 ion. But here, oxygen is more electronegative. It is holding electron from the sulfur. So oxygen is negative here. And you know very well, किसी भी compound में one should be negative, other one should be positive. और वैसे भी एक और ट्रिक है, लेफ्ट साइड वाले हमेशा पॉजिटिव होते हैं, राइट साइड वाले हमेशा नेगेटिव होते हैं. दिस इज वेरी सिंपल. सल्फर इज देयर at the left side now, and it has something like positive. And we just discussed that the valency of sulfur is -2. Here sulfur is positive. It means it is doing something different. It's not becoming -2 ion. It is not gaining electron. Someone is holding electron of the sulfur, which is oxygen definitely. Sulfur is showing its positive valency here, and we don't know about the positive valency of sulfur. So ये जो positive charge आ रहा है ना, this जो भी ये है, +2 है, +4 है, +6 है, I'll tell you कि हम कैसे find करते हैं. But this is the oxidation state of the sulfur, and that is totally different as compared to valency. Let me give you the easiest example. मैंने आज सुबह की example सुबह की क्लास में भी दी थी. जो students मेरे साथ morning की क्लास में थे, उन्होंने वहाँ मेरे साथ discuss किया है. देखिए, for example, if I say that I am a chemistry teacher, it means I have to teach chemistry all the time. That is my valency. I mean, अगर आप में से कोई आपका कजन हो जिसने नेक्स्ट ईयर पढ़ना हो, तो आप कहेंगे ओके भाई, ये जो टीचर है ना, ये केमिस्ट्री पढ़ाती है, सो नेक्स्ट ईयर भी ये केमिस्ट्री पढ़ाएंगे. दिस इज माय वैलेंसी, दिस इज माय फ्यूचर प्रेडिक्शन. बट अगर नेक्स्ट ईयर आप मुझसे मिले एंड आई स्टार्ट टीचिंग फिजिक्स एट दैट, आई स्टार्ट टीचिंग बायो एट दैट टाइम, फिर तो वो मेरी उस वक्त की ऑक्सीडेशन स्टेट होगी कि करंटली आई एम टीचिंग फिजिक्स. Although मैं केमिस्ट्री पढ़ाती हूँ, means मेरी वैलेंसी केमिस्ट्री है, but I can teach physics also. Same goes here. Sulfur should be -2 all the time, but right now it is positive. It means ये positive भी बन सकता है, multi talented है. अब आपकी मर्जी, आप positive ने इसको multi talented कह रहे हैं, आपकी मर्जी आप negative ने इसको disturbing कह रहे हैं. जिन स्टूडेंट्स को ये टॉपिक मुश्किल लगता है ना ऑक्सीडेशन स्टेट का, वो कहते हैं ये डिस्टर्बिंग एलिमेंट है. हमने तो उसकी वैलेंसी याद की -2. It is +2, +4, +6 sometimes. So this is disturbing. और जिनको ये चैप्टर अच्छा लगता है वो कहते हैं सल्फर मल्टी टैलेंटेड है. Sometimes it is -2, sometimes it is +2, sometimes it is +4, sometimes it is +6. लेकिन हमें कैसे पता चलेगा ऑक्सीडेशन स्टेट क्या है? देखिए, मेरा सबको पता, फॉर एग्जांपल अगर मेरे स्टूडेंट को पता है कि मैं केमिस्ट्री पढ़ाती हूँ और इन फ्यूचर अगर मैं इस्लामियात पढ़ा रही हूँ, तो किसी को कैसे पता चलेगा इन फ्यूचर में क्या पढ़ा रही हूँ? मुझसे आके मिलेंगे, पूछेंगे, वर्किंग करेंगे, फिर पता चलेगा अच्छा जी अब इस्लामियात पढ़ा रही हूँ. So here sulfur is positive. मुझे कैसे पता चलेगा sulfur क्या positive है? Definitely I have to meet sulfur here. I have to work on the sulfur. Then I have to find that sulfur क्यों positive है और क्या positive है. +2 है, +3 है, +4 है. This is called oxidation state, which you have to find. 90% elements की valency and oxidation state same होती है, like sodium, like magnesium, like aluminum, like oxygen. But there are few elements which are disturbing sometimes. कैसे पता चलेगा disturbing elements कौन से हैं? This is very easy. इसकी भी एक trick है. Everyone knows that metals are electropositive. ये बिल्कुल basic chemistry में है, O levels में भी और A levels में भी. Metals are electropositive. What does it mean? Metals can donate their electron and they can be positive ion, like sodium is donating 1 electron, magnesium is donating 1 electron, aluminum is donating 1 electron. So metals are electropositive. Okay. So if I'm saying that aluminum has 3 valence electron, it will donate 3 electron all the time. So its valency is +3. Its oxidation state will be +3 all the time. ये कोई disturbing element नहीं है, जो valency है वही oxidation state होगी. यानी आप समझे, aluminum अभी chemistry पढ़ाता है तो आगे जाके भी उसने chemistry पढ़ाना है. This is the simplest thing which I could tell you. So metals are electropositive and non-metals are electronegative. What does it mean? Means they can hold electron toward themselves. They can gain electron. They can attract electrons. They can be completely negatively charged. They may have partial negative charge. So non-metals तो negative होते हैं. मसला कब आएगा? जब non-metals positive हो जाएं. तब आपको परेशान होने ऑक्सीडेशन स्टेट के लिए. अभी मैं बता दूंगी आपको सारी वैलेंसीज. तो non-metals की आप वैलेंसी याद कर लें. Non-metals के लिए आपने परेशान कब होना है? जब non-metals positive आ जाए. See, NaCl. So everyone knows that sodium is metal, chlorine is non-metal. But we have a trick now, and the trick is, whatever is there at the left side that is positive, or right one negative होते हैं. So in this case, this is very easy. There is sodium which is positive, there is chlorine which is negative. जो valencies मैं आपको लिखवाऊंगी वही उठा के put कर दीजिएगा. ये +1 है, ये -1 है. Simple. परेशानी आपको कब होनी है? Like sulfur dioxide. See, sulfur is non-metal, oxygen is also non-metal. अच्छा, ऑक्सीजन तो राइट साइड पे आ गया ना, नेगेटिव वाली साइड पे. सो ऑक्सीजन इज नेगेटिव हियर. जो भी इसकी वैलेंसी हम नेगेटिव वाली अभी डिस्कस करेंगे वो आप बता दीजिएगा यहाँ पर. सल्फर नॉन मेटल, बट दिस इज देयर एट द लेफ्ट साइड. It should be positive, but we just discussed that non-metals are negative, but sulfur is there at the positive side. आप ये नहीं कह सकते कि सल्फर भी नेगेटिव है, ऑक्सीजन भी नेगेटिव है. Two negative things cannot make a bond. One should behave positive, then there will be a bond. So it means sulfur is positive here. Now you have to worry about the sulfur. Sulfur positive हो गया. Sulfur की तो positive valency है ही नहीं. Now you have to calculate the oxidation state of sulfur. Means sulfur का जो current state है वो थोड़ा change हो गया. Now you have to find the oxidation state of sulfur in sulfur dioxide. Means how sulfur is behaving here in sulfur dioxide. This is the oxidation state. So वो जो स्टूडेंट्स कहते हैं ना मिस हमें कब पता चलेगा, उसने अपनी ऑक्सीडेशन स्टेट चेंज कर लिए ऐसे जब नॉन मेटल पॉजिटिव साइड पे आ जाए. दिस इज अ ट्रिक. दिस इज नॉट रिटन इन योर बुक्स अगेन, एंड दिस इज नॉट अ रूल ऑफ केमिस्ट्री. दिस इज अ ट्रिक दैट जब भी नॉन मेटल उठ के लेफ्ट साइड पे आ जाए आप जाएं उसकी ऑक्सीडेशन स्टेट कैलकुलेट करें. इट इज नॉट फॉलोइंग इट्स वैलेंसी राइट नाउ. इट इज नॉट फॉलोइंग इट्स फ्यूचर प्रेडिक्शन. So this is the first case जिसमें you have to calculate oxidation state. And the second issue, when you have, see, NaCl, sodium is a metal, chlorine is a non-metal. Sodium is positive, chlorine is negative. That's okay. इसकी अभी मैं वैलेंसी लिखवा दूंगी, आप याद कर लें. But we have some metals and they are called transition metals. They are placed separately in a periodic table between group 2 and group 3. वो आप देखिएगा छोटे छोटे ग्रुप्स हैं उसमें. We have zinc, chromium, manganese. Chromium and manganese, they are much disturbing elements. आपकी मर्जी, अगर आपको अच्छा लगता है टॉपिक तो आप कह सकते हैं दे आर मल्टी टैलेंटेड. उनकी ऑक्सीडेशन स्टेट अपनी मर्जी की 1 से +7 तक होती है. वी डू हैव सिल्वर, गोल्ड, आयरन, निकल, कॉपर इन ट्रांजिशन एलिमेंट. उनकी वैलेंसी हमें कभी नहीं पता होती. सो अगर आपके पास फॉर एग्जांपल FeCl2 आ गया, सो यू हैव टू चेक द पीरियोडिक टेबल फर्स्ट. आई मीन स्टूडेंट कहते हैं मिस आयरन मेटल है ना, पॉजिटिव है, क्लोरीन नेगेटिव है, बट ये वो मेटल है व्हिच इज द ट्रांजिशन एलिमेंट. This is a transition metal. It is having variable valency. Sometimes it will be +2, it will donate 2 electrons. Sometimes it will be +3, it is donating 3 electrons. So when you have transition elements in a compound, you have to find their oxidation state or any current state, what they are doing right now in a compound. And whenever non-metal left side पे आ जाए, positive side पे, then you have to be worried about the non-metal. It should be negative. हमें नेगेटिव वैलेंसीज याद होती हैं बट इसकी पॉजिटिव वैलेंसी कुछ और है. लेट मी टेल यू अबाउट द वैलेंसीज फर्स्ट. दिस इज वेरी इजी. ग्रुप 1, ग्रुप 2, group 3. These are the metallic group now. We are not discussing the transition element right now. The transition elements have different valencies. They have variable valency. तो उनकी तो fix होती नहीं है. We have to calculate every time when they are there in a compound. Group 1, group 2, group 3. Group 1 elements, why they are in group 1? They have one valence electron. Group 2 elements, magnesium, calcium, they belongs to group 2. Why? Because they have 2 valence electron. Group 3, the most common, boron and the aluminum, they have 3 valence electron. These are the valence electron. Okay. All the elements which belong to group 1, they have 1 valence electron. So during reaction, they will donate their one electron. We know very well, for example, sodium, it will transfer its one electron to the non-metal to make ionic bond. It means group 1 element will transfer their electron. They will transfer their negative charge. They will donate their negative charge to other element. So they will become positive 1. Group 2 elements have 2 valence electron. They will donate their 2 electrons. They will donate their 2 electrons to make positive 2 ion. Group 3 elements like aluminum family. Group 3 elements like aluminum family. Aluminum has 3 valence electron. Aluminum has 3 valence electrons. During reaction, aluminum can donate those 3 electrons to any element, and it will become positive 3 ion plus 3. These are the valencies. The valency of group 1 plus 1. Valency of group 2 plus 2. Valency of group 3 plus 3. This is the future prediction now. For example, Al2O3. If I ask you, what is the oxidation state of aluminum in aluminum oxide? Oxidation state, I'm asking you about the current situation of the aluminum, the current state of the aluminum. So you can see aluminum belongs to group 3. Aluminum is not a transition metal. It is not a non-metal. It is there at a positive side. We know very well that metals are positive. That's not a big issue. We know very well that metals are positive. So aluminum has plus 3 valency. So the oxidation state of aluminum is plus 3. Simple. It is not non-metal कि वो positive side पे आ गया तो मैं परेशान हो जाऊँ. It is not any transition metal. What about oxygen? Oxygen को भी हम आगे discuss करते हैं. So these are the valencies which you have to learn. Without these valencies, you cannot make any equation yourself. Okay, group 4, group 5, group 6, and group 7. These are the non-metallic group. Keep in your mind, we are not going to discuss group 8 here. We are not going to discuss group 8 here. The reason? Group 8, they are unreactive. उनकी तो कोई valence ही नहीं होती. What is the future prediction for the group 8 elements? They won't react. 0, null. So we are not including group 8. Okay, group 4. The elements which belong to group 4, they have 4 valence electron. Group 5, they have 5 valence electron. Group 6 means 6 valence electron. Group 7 means 7 valence electron. Okay, let's start from group 7. Group 7 elements have 7 valence electron. Means during reaction, they will gain 1 electron only and they will become minus 1. Simple. So minus 1 is the valency of group 7 element. जहां भी आपको क्लोरीन नजर आए आप फौरन से नोट कर लेंगे -1 है किसी भी कंपाउंड. Group 6, oxygen family. Group 6 elements have 6 valence electron. Group 6 has sulfur and the oxygen. Sorry, oxygen and sulfur. Oxygen is there in a second period. No, oxygen and sulfur. So group 6 elements mean they have 6 valence electron. So whenever they react, they will accept 2 electron. They will gain 2 electron and they will become -2. So -2 is the fixed valency for group 6 elements. अब वो देख लेना सल्फर के लिए फिर -2 होनी चाहिए. जब सल्फर पॉजिटिव हो जाता है ना फिर हम परेशान होते हैं कि हमने तो डिस्कस किया था कि ग्रुप 6 वालों की -2 वैलेंसी होती है. तो जब सल्फर लेफ्ट साइड पर आ जाएगा, लेफ्ट वाला तो हमेशा पॉजिटिव होता है, द फर्स्ट वन. पॉजिटिव तो वैलेंसी में मैंने कुछ लिखा ही नहीं है. Then you have to calculate the oxidation state, the current state of the sulfur. वो हम यूं उठा देखेंगे क्लोरीन कहीं हो ना तो फौरन से लिख देंगे -1 है. ऑक्सीजन नजर आएगा आपको राइट साइड पे, आप कहेंगे -2 है. ऑक्सीजन उठ के अगर लेफ्ट साइड पर आ गया कभी पॉजिटिव साइड पे, then you have to worry about the oxygen. ये -2 नहीं है अब, this is positive. Then you have to find the oxidation state of oxygen in that compound जहां ऑक्सीजन पॉजिटिव आ जाए. ये एक ट्रिक है, ये बुक्स में नहीं लिखा हुआ, ये जस्ट ट्रिक है आपको बताने के लिए कि आपने कब ऑक्सीडेशन स्टेट को कैलकुलेट करना होता है. अदरवाइज वैलेंसी फॉलो करें. ग्रुप 5 वैलेंस इलेक्ट्रॉन, they need 8 valence electron, so they already have 5 valence electron. Nitrogen and the phosphorus, they have 5 valence electron, means they need only 3 electron to complete the valence shell. So they will gain 3 electrons, -3. Why non-metals are gaining electron? Because they are electronegative, means they can gain electron. ये metals होते हैं जो electrons को donate करते हैं. Non-metals या तो electron को gain कर लेते हैं या अपनी तरफ attract कर रहे होते हैं. अगर gain ना कर सके, attract जरूर करते हैं. Metals gain नहीं करते, metals attract भी नहीं करते, they always donate. But at higher level, aluminum जो है वो थोड़ा थोड़ा non-metallic हो जाता है. That is another discussion. Okay, group 4. Group 4 carbon family, carbon and the silicon. Group 4 elements have 4 valence electron. So the group 4 element, they are non-metal. So they can be negative. So they need only 4 electron to complete the valence shell. So carbon can attract 4 electron toward itself to complete its octet, to complete its valence shell. So -4. These are the valencies. You just have to learn the valencies. Group 1, group 2, group 3 के elements आपको कभी disturb नहीं करेंगे. The issue is with group 4, 5, 6, 7. 7 वाले भी आपको A levels में डिस्टर्ब नहीं करते, O levels में डिस्टर्ब नहीं करते, हायर लेवल पे डिस्टर्ब करते. अच्छा जी, देखें Na2S, क्योंकि आयोनिक हाफ इक्वेशन हम बनाएंगे ना आगे, सो यू शुड नो दैट हाउ टू मेक आयोनिक हाफ इक्वेशन. सो उसके लिए आपको इनको आयंस में ब्रेक करना होगा. उसके लिए आपको पता होना चाहिए कौन से आयन बन रहे हैं कंपाउंड में. सो Na2S, sodium is there at the left side वाले are positive, so sodium is positive. और sodium की valency भी हमने की +1, assign कर दें उसको उसकी valency +1. Sodium is +1 here. Sulfur is there at the negative side, right side. So sulfur is negative here, और negative valency is fixed. This is -2. -2 खत्म. अब वो हम ionic half equation में इसको use कर सकते हैं. But see, if sulfur is making sulfur dioxide, okay, oxygen is there at the right side, means -2. Oxygen is there at the right side, means -2. मैंने नेगेटिव क्यों लिखा है? क्योंकि ऑक्सीजन राइट साइड पे है, नेगेटिव साइड पर है, और मुझे नेगेटिव वैलेंसी ऑक्सीजन की पता है, दैट इज -2. बट सल्फर इज अ नॉन मेटल एंड दैट इज देयर एट द पॉजिटिव साइड, मींस सल्फर इज पॉजिटिव हियर, और यहाँ तो कोई पॉजिटिव वैलेंसी लिखी नहीं है, उसकी तो फ्यूचर प्रेडिक्शन है ही पॉजिटिव की, -2 होना चाहिए. बट यहाँ दो नेगेटिव तो नहीं बनाएंगे ना बॉन्ड, इट मींस सल्फर इज पॉजिटिव हियर. ओके, सो यू हैव टू कैलकुलेट the current valency, the current oxidation state, that is called oxidation state of the sulfur. How can we calculate? This is very easy. See, this sulfur dioxide is made up of 1 sulfur or 2 oxygen. Sulfur plus 2 oxygen. Sulfur plus 2 oxygen. Okay. We don't know about the oxidation state of sulfur. S लिखते हैं, +2. We know very well about the oxidation state of oxygen. I mean, the valency of oxygen is -2, and oxygen is still following its valency. Oxygen ने तो अपनी future prediction पूरी की है, तो वो अभी भी अपनी valency को follow कर रहे हैं. So the current state of oxygen is -2. Just put the oxidation state, or simple, just put the value of the valency of oxygen here. So plus minus, 2 multiplied by 2 will give you 4. Sulfur -4, make it equation equal to 0. Shift -4 toward the right side. So sulfur is equals to +4. +4, 0 plus 4 will give you +4 now. Sulfur is equals to +4. It means the oxidation state of sulfur is +4 here. What does it mean? ये नहीं कहिएगा कि सल्फर अपने 4 इलेक्ट्रॉन्स ऑक्सीजन को दे रहे हैं. हाउ कैन सल्फर डोनेट इट्स इलेक्ट्रॉन? नॉन मेटल्स डोनेट नहीं कर सकते लाइक मेटल्स. हाँ, यू कैन से दैट ऑक्सीजन is more electronegative, oxygen is more powerful here, so it is holding 4 electrons of sulfur toward itself. सल्फर के इलेक्ट्रॉन ऑक्सीजन के पास जा रहे हैं ना, so sulfur would be slightly positive, और उस पॉजिटिव की वैल्यू 4 है. This is the oxidation state. Sulfur should be -2. It should gain 2 electrons, but oxygen is already gaining electron. So sulfur is +4 here. This is how you can find the oxidation state of anything. Let me give you one more example. This is sulfur dioxide. We have one more compound of sulfur, no? Sulfur trioxide. This is more common. Sulfur plus 3 oxygen. So sulfur plus 3. What is the valency of oxygen? We know oxygen is there at the right side, at the negative side. So this is -2. Plus minus 3 multiplied by 2, 6. and sulfur is equals to -6 is equals to 0. Sulfur shift -6 toward the right side, it will become +6. So sulfur is +6 here. This is the current situation. This is the um, current situation of the sulfur, you can say. I mean, sulfur is having +6 oxidation state right now. Its 6 electron are holded by oxygen because oxygen is more stronger as compared to sulfur. This is the oxidation state. This is very easy. For example, nitrogen. Um, any compound of nitrogen, for example, nitrogen dioxide. Yes, we have oxide of nitrogen, NO2, nitrogen dioxide. Oxygen is there toward the right side. Right one are usually negative, -2. It is falling its valency. Sulfur is there at the left side, means at the positive side. We just discussed group 5 valency, and that is -3. We don't know the positive valency of nitrogen. That is non-metal. How can it be? How can it behave like positive? So what you have to do? You have to find the current oxidation state, the current situation, the current position of nitrogen, you can say. I mean, what nitrogen is doing right now. So nitrogen plus, how many oxygen are there? 2 oxygen. We don't know about the nitrogen plus 2 oxygen. 2 instead of oxygen. Oxygen is there at the right side. It is falling its negative valency, that is -2. So plus minus minus 2 multiplied by 2, 4. Nitrogen -4, make it equation is equal to 0. So you can shift this -4 toward the right side. It will become +4. So nitrogen is +4 here. So whenever you will make some ionic half equations, so you have to make you have to break any compound in the form of ion. So you should know what is the oxidation state of element in that compound. I mean, if you don't know about the oxidation state, so what you will do, you will say nitrogen is -3 according to its valency, it is -3, and oxygen is -2. How can it possible? How two negative things can make a compound? Nitrogen and oxygen will repel each other if both are negative. You will never get nitrogen dioxide. How we are making nitrogen dioxide? Nitrogen is also having negative valency because nitrogen is showing its positive oxidation state right now. This is called oxidation state. This is really easy. What you have to do, you all have to make, sorry, you all have to do some homework. Try to find oxidation state of sulfur. Let me show you some compounds of sulfur. Again, sulfur dioxide, sulfur trioxide, sulfur dichloride, Na2S. Try to find oxidation state of sulfur in these compounds. And for the nitrogen, for the carbon dioxide, try to find the oxidation state of carbon in carbon dioxide. Okay, let me mark with the green one. You have to find the oxidation state of sulfur. Okay, other than this, try to find the oxidation state of nitrogen in these compound. Nitrogen monoxide, nitrous oxide, dinitrogen dioxide, nitrogen dioxide, ammonia, and there was one more, sodium nitrate, Na3N. Try to find the oxidation state of nitrogen in these compounds. You can take the snapshot, or I'm taking the snapshot. I'll share it with you. Try to find the oxidation state of these elements. Whenever you are free, then you have to send it to me back, because in next class, we will discuss ionic half equation. So this is for today. See you inshallah in the next class. Till then, take care.